Hi everyone, my name is Afishena. I'm from Auckland University of Technology and my supervisor is Dr. Ramun Zamora. My research is fault protection and control mechanism of LVDC microgrid. I would like to start with, what is a microgrid? Imagine if we have one or multiple energy sources in our local area that we can connect to a main electricity grid, or we can also make it run independently like an island of power system. This is a typical power distribution system in our main electricity grid. The current flows in one direction from the power generation side to the houses, or we call it load. This kind of power system are very prone to fault. Nowadays, our power distribution systems are shifting to something like this. Loads now has its own power generator like PV for example, and a battery or a supercapacitor as its energy storage. So the power flow now is no longer only one direction but could be two. This system, although it is very beneficial, it also has its own challenges. Some of them are the protection and control system. Microgrid makes it possible for us to use local renewable power sources like solar and wind and have a backup batteries and generators to power up local homes and businesses. Why is microgrid needed? Higher usage of renewable energy resources, which leads to expanding number of distributed generators, are developing rapidly in power system architecture nowadays. Thus, there are needs to integrate different types of distributed energy resources and load with microgrid. Microgrid also enables consumers to have flexible energy utilization. Some of the biggest challenges of low-voltage direct current microgrids are, it is still in the developing stage which make it still lack of guidelines and standard. No zero crossing point in DC current makes it more challenging for the protection devices. For shipboard application, it requires higher safety requirement. Key benefits on shipboard application of LVDC microgrids includes improved power quality and more optimized loading of diesel gensets, reduced fuel consumption, reduced carbon emission, and lower maintenance cost. In some cases, it is also possible to reduce the overall footprint of power plant by removing one or more gensets.